Okay, so we're looking at lesson 2 on chemical equations. We're just going to go over some basics of what it looks like and how we do what's called balance them. So if we look at lesson 2 here, chemical equations basically what's written to describe what's happening at the atomic level during a chemical reaction. We have substances on the left, which are going to be known as reactants, changing into something on the right, which is the final products, so-called the products of the reaction. So we're going to start dealing with writing these out, and then we're going to look back at and balance them. So if we look at the structure of a chemical equation, we're just going to try to write them out. So lithium chloride is going to react with sodium sulfate to form lithium sulfate and sodium chloride. Here's where we spent the time naming these so we can learn how to write these out. So lithium chloride will be written as LiCl. Okay, we have that reacting. So whenever you write reacting with, you're going to write that with an addition sign. Sodium sulfate would be Na2SO4. That is going to form, so I'm going to use an arrow to show forming, lithium sulfate, Li2SO4, and we're going to have sodium chloride. Okay. All right, the second one, iron's reacting with oxygen and yielding iron 3 oxide. So iron reacting with oxygen. I'm going to tell you right now, oxygen is going to be written as O2. We'll come back to that in a little bit. Why? Iron 3 oxide is going to be Fe2O3. Silver nitrate reacting, so silver nitrate is AgNO3. Reacting with hydrosulfuric acid, that's H2S. It's going to produce silver sulfide, so Ag2S, and nitric acid, which is HNO3. Okay, so first step, just learning about how to write these out. Whenever you see forming, you're using arrows. If they're two of the same thing, so two reactants or products, you're going to use addition signs. So law of conservation of mass basically says matter is not created or destroyed. They're just rearranged. That means we can't gain or lose anything as we go throughout a reaction. So we're going to need to take that into account with what's called balancing reactions. So to balance this equation here, we need to kind of look at a different count of each element on the side. So you can write these out if it helps you. If you don't need this step, then that's great. So we have hydrogen, H2 reacting with O2, forming water. So what I can do is on each side kind of write out a count. So on the left, I have 2 hydrogens. I've got 2 oxygens. On the right, I have 2 hydrogens and 1 oxygen, okay? So I can go ahead and look at these and make sure they match. So 2 hydrogens checks out with 2 hydrogens. 2 oxygens and 1 oxygen. That's going to be a problem. I have to think about how I can get these to match. In order to figure out how to get these to match, one of the easiest things we could do is multiply this by 2. And then it will match. But in order to do that, though, we can't change any subscripts. I can't simply write a 2 after the oxygen here. That would make it hydrogen peroxide in a different compound. We have to use what's called coefficients and write it out in front, okay? So if you need to do something like this and box it in to remind yourself you cannot write in the box, go ahead and do that. You have to write the number out front. So I need 2 oxygens here. I'm going to do that by putting a number out front. Now that means, though, that I also doubled the number of hydrogens. By putting this 2 here, this multiplies in, so 2 times 2 gives me 4 hydrogens. So since I have 4 hydrogens on this side, I now need 4 hydrogens on this side. To do that, I'm going to multiply by 2, meaning I need a 2 here. Now I'm good to go. It'll be 2, 1, 2. So if I read this question here, assuming all reactants react, you start with 5 grams of hydrogen, 4 grams of oxygen. How many grams of water should be produced? Well, what we really need to do is just kind of add these up to make sure we're not losing any mass. So if we have 5 grams of hydrogen, 4 grams of oxygen, we're going to kind of have 9 grams altogether if we add these together. We're going to work on some more complicated calculations dealing with this kind of thing in the next unit, but for right now, just know that the mass of the products and the reactants need to be the same. So if we've got 5 plus 4, 9 total grams on the reactants, we need 9 grams on the product side. Okay, so when we look at these reactions and balancing them again, so first thing we're going to do is just kind of write them out like we had them before. So we've got lithium chloride once again as LiCl reacting with sodium sulfate to form lithium sulfate. Make sure you can see that's an arrow, not an addition sign, and sodium chloride. We had iron reacting with oxygen, yielding iron 3 oxide. And then we had silver nitrate reacting with hydrosulfuric acid to form silver sulfide. So that would be Ag2S and HNO3. Okay, so Now we need to make sure these are balanced. So we'll start back at the first one. So again, if you want to do this kind of count again on the side, go ahead. So I'm going to look here. I'm going to start left to right. I recommend if you have oxygen or hydrogen to treat those last. Sometimes those get confusing. So first thing here, I see lithium and lithium here. So one on this side, two on this side. Just know that some of this becomes guess and check. You might need to erase and try again, and that's okay. All right, so because there's only one here and two here, I'm going to start with a two out in front. Now my lithiums are okay, so I'm going to keep working on it. So I'm going to keep going. So now I have chlorine. I now have two chlorines on this side, 2 times 1. There's a subscript 1 here. So 2 on this side, 1 on this side. To try to combat that, I'm going to put a 2 here. All right, now lithium and chlorine are good. Sodium, I have 2 here, and now I have 2 here. That's okay. I recommend treating this whole thing as 1. It'll be a little easier if you count that as 1 sulfate, and I have 1 sulfate here. So I'm good to go. So 2, 1, 1, 2 are the numbers you need. Next one, iron reacting with oxygen. So I've got iron. I only have 1 on this side, 2 here. I'm going to try to combat that with a 2. I'm going to keep going. Oxygen, I have 2 here and 3 here. The only way I can get 2 and 3 to be equal is using their least common multiple, which will give me to 6, which means I need a 2 here and a 3 here, okay? So now I have 6 oxygens and 6 oxygens. But check this out. Now I have 4 irons. So that's okay. I just need to change this from a 2 to a 4. Last one here, silver nitrate, 1 silver, 2 silvers, put a 2 here. Now I have 2 nitrogens, treating this as a group, or sorry, nitrates, I should say. Then I only have 1 nitrate right here, so I'm going to add a 2 out in front. Now I keep going. So I've got 2 hydrogens, 1 sulfur, I'm good to go. And that's it.